Okay, so today's task, going back to this problem again because, well, one similar to it appears on our quiz tomorrow. I'd actually be developing some artistic talent. Coping skills, one of the two. I'll give you a minute to make sure you have that whole drawing down. For a problem like this, there are two ways to approach it. Both involve finding something bigger and subtracting out the missing. I could find the volume of the whole box first, and then subtract out the volume of this missing slot here. Or I could find the area of this piece here, which would involve finding the area of the whole rectangle and then subtracting out that missing slot. And then multiply that area by the 30 millimeters of depth. Either way, it's basically the same thing. I'm subtracting out that cutout either way. So let's find volume of the whole box. Well, that's simply going to be length times width times height. Or we could have done 80 times 30 to get an area of a base and then times the 25. We're going to take the shortcut and just multiply them all together. I believe that comes out to be 60,000. Hamster might actually be on the wheel this morning. So 60,000 cubic millimeters is that whole volume. So now we've got the difficult part, subtracting out this piece here. Well, let's find that features of that segment. First of all, I know that it is 30 millimeters across here. And what's the depth here? Oh, perfect. Send that up. My x. Split this in half to be 15 and 15. What is my formula for finding x? Times 15 equals 12 times x. So we solve that for x. And unfortunately, it comes out to be a little bit ugly. What do we get? 5 equals x. The diameter of our circle is 5. Making the radius 15. That means that is 15. We need to find the area of that segment. Find the area of the segment. We start by finding the area of that whole sector. To do that, we need to know that angle. In your notes, figure out that angle for me. Find that angle. We're going off of this right triangle. That's half of that triangle. So this is 15 millimeters. This is 15.375. Now, as you can guess, this angle is actually going to be awfully close to 90 degrees. How do I find the angle? First sine. Very good, because that is the opposite side in the hypotenuse. We're going to do an inverse sine. Second sine of 15 over 15.375. Get, oops, my modes. $77.32 degrees. Which means that whole angle is how much? 154.64 degrees. Then how do I find the area of the whole sector from that? We start with pi.
Pi times.
Perfect. Pi times our radius of 15.375 squared times that central angle of 154.64 divided by 360. $18.84. Next, we define the area of the triangle. It's going to be a very small area. I know this triangle here has a base of 30 millimeters. Height here, 3.75 millimeters. Where did I get the 3.375? Perfect. The whole radius of 15.375 minus that 12 millimeters that was already there. That area, 30 millimeters times 3.375 millimeters by 2. $50.625, $50.63 I'm going to call it. What do I do with those two measurements? Subtract them. Very good. 268.21 millimeters squared is the area of the segment. What am I going to do with that? And the volume of that cut, the volume of material removed in that cut. How am I going to do that? Perfect. Times the 30 millimeters, which is just the depth of it, or height. That's 8,046.3. And we just subtract. Giving us a volume, 51,953.7 millimeters cubed. Asked for is mass in kilograms. Go down here, 953.6. Density, what did I give? 67 grams per centimeter. And I want my mass. So I have some converting to do here. First, my density is given in grams per cubic centimeter. So that means I need my volume in cubic centimeters. 51,953.7 cubic millimeters becomes how many cubic centimeters? On our chart, from millimeters to centimeters is one spot to the left. So 3 because it's cubed here. 51.9, we're just going to go 9.5. We'll go 95737. Go all the way up. Cubic centimeters of volume. Now I can just put that over 1 and use my density. Get rid of the cubic centimeters, I put cubic centimeters on bottom. 67 grams per cubic centimeter really means 67 grams is equivalent to 1 cubic centimeter. So the cubic centimeters will cancel out. And I multiply my 51.9537 times 67. We're going to call that 3,480.9 grams. Of course, I want it in kilograms, which means we have to. Decimal point, how far? .48 there kilograms. Just under 3.5 kilograms. What we're going to look at here, we got a piece of a circle with a couple of tangents coming out. It is tangent at both of those points. I'm going to give you the diameter of the circle. I'm going to give you the distance from the corner to that tangency there is also 60 millimeters. Over here is 30 millimeters. I want you to find the length x. Angle here, A. And stay consistent with what we've done, area of that shape. Now, totally unlike my nature, I did something here very kind. Something nice to you. What that is has to do with this dimension compared to this dimension. What it is? Yes, that 30 is the radius, which means that point lines up with the center of the circle. That'll be a right angle there. Since the radius here would be a right angle as well, that tells us that forms a triangle. This radius out, that forms a right triangle as well. So we have, or sorry, forms a rectangle. We've got a rectangle on bottom and a right triangle on top. Makes our lives a lot easier. This, of course, is 30 millimeters. It's also a radius that's also 30 millimeters. Here is 60 millimeters. Right away, I have an easy way to find x. Got it. Using our a squared plus b squared equals c squared, but we're going to work backwards. So we got 60 squared minus 30 squared and then square root. Giving us 51.96. Millimeters. Next, we can find this angle right here. Careful. Oh, the opposite side. This is the. Actually, you're absolutely right. You should have used. I was looking at that side. I was thinking you're at inverse sine. It's opposite and hypotenuse. Sorry. Maybe the little hamster isn't totally on the wheel. I get freaking all excited. It's inverse sine of 30 out of 60. Steve is going to give us 30. So if that's 30 degrees, say 120. Very good. Got 90 degrees down here for this right angle, plus the 30 gives a total of 120. Those two parts came really easy. For our area, I have piece 1 here is a rectangle by 30. They give us piece 2 here, triangle. Unfortunately, I do have to use the 51.96 times 30 to triangle. Is 779.4. Sector of the circle, I need to know that angle there. In fact, I already do know it. Can anybody tell me how to find it? Yep. What's it going to be? Go the 30 degrees over there with the 90 for the right angle. That one has to be 60. You also have the right angle down here from the rectangle. Total of 150, which leaves this angle has to be 110 degrees. So that area, pi, we've got 1/4 times
30 squared.
Squared times 10 over 3. $48.5. $4,227.9 millimeters squared is my area. Not so bad. Like I said, I was very, very nice there and made that side line up with the center of the circle. If I don't do that, if I'm in a normal mood for the day, let's say that the circle has a diameter of 80. Make that 50. And this distance here we'll look for length x and angle A. The area, I'm going to assume that once we find all these shapes, the area can be. So I am still going to locate the center of my circle here. Problem is, as you can see, that center does not line up that angle there. So I got to draw a right triangle in like this. Fill that out. So I do still have a rectangle here, 40 by 90. It just doesn't come all the way up to this corner like I wished it. Now I've got to look at that triangle, that little sliver. That's a right angle, and I know this bottom side is 90. Side over here. Yeah, good. 50 minus 40 gave us 10 millimeters. There are two things I'm going to need from this. I'm going to need the length of this side. How do I find that? Square root of 90 squared plus 10 squared. Gives us 90.554. Second thing I'm going to need, this angle up here. Inverse tangent. Opposite adjacent. Inverse tangent of 90 over 10 is 83.66 degrees. Next, I'm going to turn my attention to this right triangle here. I know that's a 90-degree angle. I know that this over here is 40 millimeters, and this down here is 90.554 millimeters. I can still find x using squared minus b squared gives us a squared. Square root. Five 4 squared minus 40 squared. 81.24. Or x. This angle right here, found from what? I literally use any trig function because I know all three sides, but I'll use the 40 and the 90.554, which would be which trig function? Forty is the opposite side. The 90.554 is the hypotenuse. Inverse sine. There's 26.21 degrees. So now A at 26.21 plus the 83.66 we had before, giving us a total of 9.87. I mean, it's not tremendously worse, but life would have been way easier if it lined up. Really want to make it worse. At that point, not a tangent. So there's an attached worksheet in Blackboard for you to work on. Tomorrow, Thursday, I'm dedicating our class to a quiz that is posted there. You guys are in class tomorrow, right? For those of you in the room here, I'll get you a hard copy of that quiz. That's all we're doing tomorrow is the quiz. But even those of you that'll be at home for class, feel free to log in, because we're at that point where I don't expect you to necessarily do. I'm going to allow open discussion amongst you guys for the quiz. I'll be online at home, logged in if you have any questions for me. You might have to say my name a couple of times to get me to click that you're talking to me instead of each other, but I will be there.
Todd, wake up.
This is